where we tell you new news you didn't need to know, but you're knowing it now.
I'm Polly Lockett.
And I'm Penny.
And welcome to our show. Today's show is going to focus on TAKS chemistry. So here's just a couple things you need to know.
Wait, taxes?
No, TAKS, the Texas Assessment something or another.
Oh, because I did mine. Just saying, Mr. IRS Auditor.
Okay. Anyways, salt, brine, and tap water all can conduct electricity through water, unlike sugar and cooking oil. Penny, do you have anything?
Now, I got a question for y'all. How does temperature affect density? Well, I got the answer. Heating a substance causes molecules to speed up and spread slightly further apart, occupying a larger volume that results in a decrease in density. Cooling a substance causes molecules to slow down and get slightly closer together, occupying a smaller volume that results in an increase in density. Hot water is less dense and will float on room temperature water. Cold water is more dense and will sink in room temperature water. Now, a physical change. A physical change is a change that occurs when something changes its form, but not its chemical composition. Some examples of this is like chopping wood, melting ice, the stuff you can put back together. A chemical change occurs when a substance's chemical composition is changed, such as burning or rusting, like my bike.
Well, that was exciting. Well, it seems like we have some technical difficulties trying to reach Periwinkle, so we'll show you this picture of the periodic table in the meantime.
I don't want your lonely mansion with a tear in every room. All I want is to love you, promised beneath the halo moon. But you think...
Well, we hope you enjoyed that image. Well, now over to Periwinkle for a couple segments. Enjoy!
Hello everybody! Welcome to Ionic Compounds with Periwinkle. Okay, so guys, so now we know that ionic compounds are basically compounds with a non-metal and a metal. So let's get started. Okay, so that we know, whatever. So now that we know that, for example, NaCl, table saw, if you didn't know, you're done. Okay, so Na and Cl. Okay, so to form these compounds, we have to know the charge for each compound, or element I should say, I'm sorry. And we know that the Na has a charge of +1, and Cl has a charge of a -1. Okay, so now, what we're going to do is form these and make them come together. So, to do that, we are know that Na and Cl are going to come back down and they're going to be together. And these things right here, these charges, are going to flip. I know, how festive. So, if these charges come down, that means, yeah, the Na is going to have the -1 charge, yeah. And the Cl is, you guessed it, it's going to have the +1 charge. So, with that being said, this eventually just goes down to being a regular NaCl, which makes things neutral! Okay, there we go. So now let's have another example right now. We can do this by ourselves. Okay, ready? Let's go. So now, can you see, you can see this, right? Okay. So now we have magnesium sulfide. Sounds awesome, I know. So we know that magnesium has a charge of +2. +2, and sulfide, to make it neutral, has a charge of what? You're right, -2. Let's do that. So, okay, voila, 1, 2, buddy, boom, bomb, beam, whatever. Magnesium sulfide makes neutral, and those, you have it, guys, are ionic compounds with Periwinkle. Now for our second segment, we are going to be joined to balance equations at the table. So guys, we know that to balance equations, we have to have the same number of elements on each side. Up here I have an example. We know that we have a total of 2 potassiums on each side and a total of 2 chlorines on each side, and a total of 6 oxygens in it. Festive. I know, boring, whatever. So, we're gonna do this together, juntos, para siempre. Okay, so now we have an equation that says S8 plus Cl2 goes to S2Cl2, whatever that is. Okay, so to make these both equal, we are going to see, okay, we have 2 chlorines on the first side, and we have 2 chlorines on the second side. So let's just drop the chlorines for right now and just whatever. They're like nobodies. And let's go back to the sulfurs. So we can add, right, see, 4 right here to make the sulfurs equal to 8. And that makes this 8, and that also goes from this sulfur and also to the chlorine and makes chlorine 8 as well. So now that we have a total of 8, these 2 equal right here. But the chlorine still is not happy, guys, and we need to make our elements happy whenever we balance the equation. That's the whole point, okay? So, what can we multiply 2 by to get a total of 8? Well, let's see. If I did my math right, I think we should do it by 4. Hello. Yeah. And if we multiply this by 4, and we just add 1 on this side, we should get an equal number of elements on both sides. Hallelujah. How you doing? Okay, guys. Well, thank you for joining me today. I am Periwinkle. And now join me again to interview... Sorry. 2 random bystanders to learn more about chemistry. Let's go. Hi, everyone. Periwinkle here. We are here with Miss Cassie, bystander from our last 2 previous webisodes, and also joining her are
Sharon Needles.
Festive. We're gonna have a fun party on these steps. Hallelujah. Okay, so let's start off by asking Miss
Sharon Needles.
Yeah, Sharon Needles. Yeah. Questions over acids and bases and other things. Right. Okay. So, Miss Needles, let me ask you. Can you identify or give us some examples of an acid and base?
Well, oven cleaner, drain cleaner, baking soda, bleach are all bases, while carbonate, battery, lemon, and lime are acids.
Yeah, what do they taste like? Like, do you know?
Well, bases taste really bitter, and acids taste really sour.
How do you know?
Google, of course.
Ew. Okay, yeah. So, what do either of those produce in water?
Well, in water, they become weaker.
And what color do they create on the litmus paper?
Acids are red, and bases are blue.
Interesting. Okay, so what happens when you bring those 2 together?
They start forming neutralization reactions.
OMG. Okay, so I know now, Miss Needles, that there are also different things in chemistry that involve phase changes. Let's do this. Okay, so can you answer me this? Can you show the difference in the molecules in each state of matter?
Well, of course. In a solid, things of matter are really close together. In a liquid, they become further apart. In a gas, they're really far apart, and they move everywhere.
Oh my god, what a party. Sounds like a party. Yeah, now I'll need to have like 5 different words I need you to define for me. And let's start off with...
Actually, it's 6.
Is this your job? Didn't think so. Thanks. 6 different words, yeah. Let's start off with sublimate. What does that mean?
It means to purify a substance.
Now, what is deposition?
A phase change from a gas to a solid.
Yeah, and can you tell me what melting is?
A phase change a phase change from a solid to a liquid.
Wow. And let me tell you what solidifying is.
Going from a liquid to a solid.
What about vaporization?
Going from a liquid to a gas.
And condense, our last and final definition.
Going from a gas to a liquid.
How festive. Now, ladies and gentlemen, please join us with Miss Cassie Bystander, who is obviously dying from this weather. Okay, so Miss Cassie Bystander, can you tell me what polarity is?
Polarity refers to a separation of electrical charge leading to a molecule or chemical groups having an electrical dipole or multipole moment.
Yeah, great. Now, tell me, why does ice float on water?
Because it has a less density.
OMG. Yeah, and why is water considered the universal solvent?
Because of so many things that will dissolve in water.
I did not know. So now I have 3 types of solutions that I want you to give me examples for. Are you ready?
No.
Are you ready?
No.
Are you... Whatever. Okay, so let's start. What is an example of a saturated solution?
A saturated solution is containing as much precipitate as possible.
And what about a supersaturated solution?
When it has more precipitate than solution.
Lovely. And what about an unsaturated solution?
It doesn't have a lot of stuff in it.
Lovely, lovely. Now tell me, Miss Cassie Bystander, how will students be able to answer questions on a solubility graph pertaining to solubility?
As the temperature rises, so does the solubility.
Oh, I have one more question for you. Are you ready?
No, probably not.
Isn't she lovely? Well, if gas solubility depended on pressure, temperature, or both?
Temperature.
Okay. And there you have it, ladies and gentlemen. We have here Miss Sherry Needles and Cassie Bystander. Thank you for joining us today. Back to you, Pauline and Penny.
Here we go.
Now that I'm not freezing my butt off and Periwinkle isn't here to annoy me, I'm going to answer the question about the conservation of mass. The conservation of mass is that it cannot be created or destroyed. It is conserved over time, which is why you have to balance an equation. Duh.
Oh. Hey, Penny! What? Wake up! It's your turn. Hey. Well, Perry Winkle, that was an awesome segment. Thanks. And for all of you out there, if you didn't know, making food is also a chemical change. So I'm gonna go make myself a cheesecake. Deuces, none for you. Let's go.
Thanks. Right, well that's the end of our show. So thanks for tuning in again, and we'll see you next time.
I don't